A sphere of mass m moving with velocity u collides head-on with another sphere of same mass which is at rest. So here sphere of mass m moving with initial velocity u1 equal to v. It collides with another sphere of same mass m which is at rest, means u2 equal to 0. Now after head-on collision, the ratio of final velocity of second sphere, suppose first sphere moves with final velocity v1, second sphere moves with final velocity v2. So the ratio of final velocity of second sphere, which is v2, to the initial velocity of first sphere, it may be u1 or v2 divided by, you may say v2 divided by v, that we want to find out. And E is coefficient of restitution. E is coefficient of restitution. Now according to law of conservation of momentum, by law of conservation of momentum, law of conservation of momentum, total momentum of system before collision is equal to momentum of system after collision. Momentum of system before collision is equal to momentum of system after collision. So before collision, what is the momentum? m1 u1 plus m2 into u2 is equal to m1 v1 plus m2 v2, m2 v2. So that is m into u1 plus m into 0 is equal to m v1 plus m v2, m v2. So m on both sides get cancelled. So we had u1 is equal to v1 plus v2, u1 is equal to v1 plus v2, or v1 is equal to u1 minus of v2, v1 is equal to u1 minus of v2, say equation number 1, equation number 1. Now coefficient of restitution, coefficient of restitution. What is coefficient of restitution is defined? Coefficient of restitution E is equal to change in final velocity upon change in initial velocity, v2 minus v1 divided by u1 minus u2, that is equal to v2 minus v1 divided by u1 minus 0. So E is equal to v2 divided by u1 minus of v1 divided by u1, or v2 divided by u1 is equal to coefficient of restitution E, and this negative term will become positive, v1 divided by u1, v1 divided by u1. Now put the value of v1 is equal to, from equation 1, so we have v2 by u1 is equal to E plus, now in place of v1 what we can write? u1 minus v2, and that is divided by u1, that is divided by u1. So v2 by u1 is equal to E plus u1 by u1 minus v2 by u1, that is v2 by u1, and minus term will be taken to this side, again it is v2 by u1, and that is equal to E plus u1 by u1 is 1, u1 by u1 is 1. So here we are having two terms, so it is 2 times v2 by u1 is equal to E plus 1, therefore v2 by u1 is equal to E plus 1 whole divided by 2. But what is v2 by u1? Final velocity of second body to the initial velocity of first body, that we want to find out. So that ratio is equal to E plus 1 by 2, E plus 1 by 2. So option A is the correct option for this question. A is the correct option for this question.